Hello everyone, welcome to this Pytorch deep learning tutorial. And now we're going to check how to use the pre-built datasets from Pytorch. And these pre-built datasets are very important. It's very useful in terms of learning the deep learning, learning to build the deep learning neural network, because it can save you plenty of time. You can use those pre-built datasets and you can go just easily jump into the building your neural network, and then use this data set to train your neural network and see the output straight away, rather than putting lots of efforts on collecting your own data sets and cleaning it up and classifying them, labeling them would be very tedious. So this pre-built data sets will save you plenty of time by cutting down that process. So obviously, if you wanted to build your own model, or if you wanted to, in order to solve the particular problem, you have to build your own data sets. But in terms of learning, these pre-built data sets are very useful. This could save you all of your all of your learning time. And Pytorch comes with lots of pre-built data sets, and it's very easy to use, and even the APIs are really simple and easy. Now we're going to check how to use one of the computer vision data sets. We are going to use the data sets which could have the images and the classification, and let's go and check how to use those data sets. Cool. So this is our Jupyter lab, and just created one notebook, and I am going to say import torch. That is our default import, and we have to import one more thing, which is Torch Vision. Torch Vision is a package which consists of all the pre-built data sets. Very popular data sets. It also has the very popular deep learning models, and this comes very handy in case of learning. And even you can use those models to solve your own problems as well, because you can just create a pipeline by building your own neural network, and and using this pre-built models to combining to them, which could give you a hybrid architecture, and that could solve your problems much more easily and and in faster way. So this is the Torch Vision package, which comes with a lot of data sets. These are the data sets. MNIST is the data sets which we're going to use now for this tutorial. MNIST data sets consist of images, number images, hand-drawn number images, 0 to 9, and then it also consists the labels, the numbers 0 to 9. We're going to use that use that as a training and test data set. And it also consists a lot of other data sets, and Coco is very famous one for the post recognition, and ImageNet is useful for the image classification. And there are other popular data sets you can just use straight away by just by getting to know some of the simple APIs of Pytorch. This also has some pre-built models, classification, semantic segmentation, object detection stuff. So feel free to just explore this. And so we're going to import this package, and if I just click play, it's all included. All the packages are already installed with my Pytorch, so it works nicely. There's no error, and we're gonna add two more classes, import two more classes from Torch Vision. For that, I'm gonna say from Torch Vision can import datasets and transforms. And transforms, I'll say why we are going to use transforms. So we're going to download the two datasets from, two datasets, one for training and one for testing from MNIST. For that, I'm going to create one variable, train datasets dot MNIST double quotes, and let's say download true, and before that you can add train is equal to true. So if you say train parameter as true, then it'll fetch the training data set. And why we need the training and test data set, that also I will tell you. And here as a last parameter, we're gonna say transform is equal to transforms dot compose is equal to transforms dot to tensor So here what we are doing, okay, let's create one more, let's download the test datasets too. I'm going to say this as test and make train as false. So why we are separating a dataset into a training dataset and a testing dataset? Because the training, during the training process, we are going to train the model, train the neural network using only the trained datasets. We are not going to use the test datasets because you need to keep some of the datasets, in this case it's images, away from the neural network, because we wanted the model to predict the the dynamic inputs, the random inputs. This will give the generalization to the neural network, because the neural network has to predict the output based on the features available in the sets, not by the exact images if you feed into. Because like if you feed all of your, if suppose you say that if you have 100 images, and if you fed all of your 100 images into your neural network, then your neural network would have seen all of your 100 images from your data sets. So it would be able to predict all the 100 images into from your data set. But if you give a new images which you would have not seen by the neural network, it can't predict exactly the way you wanted. So you need to train your model with 80% of the the samples you have collected. Usually the training and testing separation ratio would be 80-20. So if you have the 100 images in a data set, so 80 images would go to the training data set and the 20 images would go to test data set. So this is the way you can generalize generalize your neural network, and also reducing the overfitting of your neural network. If you overfit your model, like a neural network, then it won't predict the exact output. It would only predict the images which you used during the training purpose. It won't predict the proper output when you're feeding some random images. So what we are doing here, we are just using this dataset API. We're just gonna download the MNIST datasets into our local machine by calling the MNIST function and passing this parameter, and I'm gonna say the train parameter as true, so that it will fetch the train datasets from the MNIST, and I'm going to say download true. And transform classes are very important in terms of in case if you are doing some image processing at tensor level, it'll be very useful. Here what we are doing is we are just transforming the images into a tensor values. So we are just calling transform.compose and just saying here transform to 2 tensor, which means it just load the images as a load the images with tensor values. Tensor values, what is tensor values? Yesterday we have seen the tensor. Tensor usually consists of floating point numbers. So, but images usually comes in byte value. Byte value is nothing but 1 to 255. So you have to convert that 1 to 255 value to 0 to 1. So in a way you have to normalize all the pixel values into 0 to 1. So here that's what happening, and it's also transforming the shape of the image into kind of a tensor shape. Tensor shape is nothing but the depth and rows and columns. That's what we're gonna see down here. And so you can also use the transform to scale up your pixels, and you can also resampling, can also do some resampling. There are some APIs you can just go, even it can also be used to crop your images as well. So you can just play around with it in case if you're going to build your own data sets, because the image which we collect on our own would be having different sizes, but in terms of feeding into our network, we have to convert all those images into one single size. So in those cases, it will this kind of functions are very, very handy. It will crop or just clean up all your dynamic size images into one size. So that's a basic of transforms. Here we are just merely converting all the images as tensor values. So I'm just saying transform to 2 tensor. So I'm gonna hit play. Okay, here we got some error. Oh, we have done some spelling mistakes here. So this should be transforms, and if you hit play now, it should work. Okay, now it started downloading the dataset into our local machine. Woohoo! Oh, there you go. Our dataset is downloaded now completely. So here you can see the new folder is MNIST folder is created. So you can go and check. This is the training datasets. Training image, and this is the training labels, and this is testing images and testing labels. And yeah, I think this has been done in some sort of Pytorch format, or maybe some, I don't know, the PT format. And the images are very small in size. This has just 28 by 28 pixel size, and it also comes in, I think, grayscale, which means just it contains 1 byte, which means 8-bit data. So let's go and load all this, the local data sets into our memory. For that, I'm going to create one variable called train set, and gonna say torch dot utils dot data loader. I'm gonna mention the train data set, and batch size. I'll tell you what is batch size. Is equal to 10, and shuffle is equal to true. And we're gonna make one more variable to load the test set, and here we're gonna mention test dataset. So what this will do, this function, from the utils class, will load the local dataset into our memory, and this will load the test dataset into the memory so that it will be available in RAM, because it would be ready to pass into our neural network. So what are these parameters? This is the local pointer handle, dataset handle, and sorry, this is batch size. What this should be a batch size. So what is the batch size? Batch size is nothing but how many samples you're gonna feed at one time into a neural network while the training process. So if I say 10 here, which means you are sending 10 samples, which means 10 images at one go into a neural network. So it will create, this batch size would be, because you don't have to send images one by one into a neural network, because it will take a lot of time, since you have good memory, and if your image size could fit into, if your 10 image size could fit into your memory, RAM, or in case of GPU it could be VRAM, then you can just increase you can keep this batch size from 8 to 64. So this will reduce your training time if you just use the batch size as larger value. So it depends on your machine configuration, so you can just go for playing around with the batch size. I'm just keeping some reasonable. So let's jump into the next parameter, which is shuffle. Why we need the shuffle here? We're just keeping the shuffle as true. We need the shuffle because if you have one set of data, and if you're feeding into your neural network, it will figure out the way how to what kind of input images I'm getting. The shuffle will give the the randomization to the input to the input of the neural network. so that the neural network would not be able to predict what is coming into the network in what order, because you're changing the order of the data set here, so that you're creating more dynamism in the input side. Although you are using the same data sets and you are going for multiple iteration using the same data sets into a same network, but still you are adding some dynamization by just calling the shuffle here, so that like shuffling the same data set and feeding into same neural network. And I mean, like, it will create some sort of like randomization and general it will give you more generic output, so that like the neural network go for predicting the the unknown features, rather than rather than just overfitting to the exact inputs you're feeding. I hope it would make sense. So this is just for like adding more dynamism into your into your data sets, so that like, I mean, we are trying to make make the neural network not to predict the values, I mean, like, easily. It has to predict the values based on the, I mean, it has to predict the outputs based on the features rather than the exact image. So if you click play now, so all these data are loaded into the memory now. So we are going to simply print the output here, little data in train set. We're going to simply print the output of this training set. I'm going to say break here because we are going to print only one value, one sample. So there you go. You can see the output here. So all is showing 0 because like it's not showing the exact, because it's showing the entire array of images. So I'm gonna say shape. So the shape is here. You can see the shape of the 0th element is just 10, 1, 28, 28. 28 by 28 is the image size. So this is the 28 by 28 pixel, and this is the depth value. If it's not RGB, if it is a RGB, which means red, green, blue pixel, then this value would be 3. But here it's 1, which means it's just a grayscale image. And why here the number is 10? Because the batch size is 10. If you change the batch size, this number will be your batch size value. So this tensor, the loaded with just 10 samples and the 28 by 28 grayscale image. So we are gonna say so this is the image, but one sample consists one image as well as one label. So we are gonna print the label as well. So label is presenting in the first index of the data. So we will print that too. So there you go. It consists of it shows only 10, which means it contains 10 one-dimensional array values. We're going to print the output as well by saying so these are the image values. Here you can see some values. Rest of them are zeros. So we can also see the image by matplotlib, and we can also see the output of other labels 0. Let's just comment this for the sake of clarity. So this is 2. 2 means it's the value is 2. The element, the inside element is 2. So we are going to import the matplotlib pyplot in order to show the image as an image, and say plot.imshow data 0. This should show the first image. So why is it? Okay, because we are just accessing the index of the depth. Here is the actual pixel. So if you print this, yeah, there you go, it's 2 now. So the image is showing the hand-drawn 2, and you can also print the respective label of this image. Print in the data first index comes with labels, and I'm gonna print the 0th element of the label, and this is the 0th element of the image. So this should print 2. There you go, tensor 2. So here 1 means label. One first index is label. I mean, you can say classification, classifier. And 0th element is image, 28 cross 28. We have to mention 0 here because in case because it's 1 cross 1 by 28 by 28, because this is the grayscale. In case if it is RGB, then you can print the 0 1 0 1 2 in order to get the red pixels, green pixels, and blue pixels. So since it has only 1, still you have to mention the the array element, I mean array index here. So this is the multi-dimensional, three-dimensional array. Actually, if you say it's a 4-dimensional array, this is a 2-dimensional array. And yeah, so let's go for accessing the next image. 1, and here 1. So here just 1. It's not, it could just happened accidentally, but it doesn't have to be 1. It could contain any numbers, any image. So I would say 5. So it would print the, again 1. So it's a different one here. So that's it for this tutorial, guys. Here we have seen how to download the MNIST datasets into your local machine, and then how to load the data sets into your memory, and also we have seen how to visualize those data and the labels, I mean like the data sets, the images and the labels. So these are the basics. You can just play around with it. Let's meet on next tutorial. Thank you. Cheers.